We are Team Hack Titans, and the problem statement which we are tackling is automated vulnerability assessment and pen testing tool for CCTV cameras and DVRs. Nowadays, CCTV and DVR system are super vulnerable. Most of them are online with weak passwords, open ports, and outdated firmwares, and that's a huge risk. That's why we have tried to build an automated vulnerability assessment and pen testing tool for CCTV cameras and DVRs specifically. It's smart automated tool that can discover devices, check for vulnerabilities, and generate reports all just with a single click. Basically, what used to take hours manually, our tool can do it in minutes. Fast, easy, and hands-free. I will try to give you a technical overview about the whole tool. So, from the dashboard, whenever the user will click on discover, that request will go to the backend using a task quick, so nothing blocks our UI. As scan can take a lot of time too, ranging from seconds to minutes to even hours, depending on the network. So we have used Redis and Celery to background our scans too, and to manage them properly so that the UI won't get any interference. Then the worker picks up the task, find devices, scans them, and save the results in the dashboard, sorry, database. Then the UI fetches the results and you can view them or download the report. Yet the report generation is in work in progress and we will be doing that soon. For this demo, our team has tried to simulate an CCTV camera via MediaMTX and FFmpeg. So these both tools just are used to simulate an CCTV camera environment and nothing else. The FFmpeg uh, pushes the video frames to MediaMTX and then the MediaMTX pushes it forwards to the network. Just to give you a live example, I have started the server and forwarded the frames to. If I go to the IP of this machine with an port 8888, I should be able to access the camera. Yeah. So as you can see, the live stream has started and it's basically how the general flow of CCTV camera is there. So I have currently not used multiple cameras, so there was no need for the ONBIF. So let's move towards our tool. So in the demo of the tool, the things which will be covered are discovery of the discovery of the live host, scanning of the network, running few scans, trying to see which web directories are accessible or present, and then URLs if we are able to find any of them. So the tool is composed in Docker, so no need to worry about the operating system or the versions. You just need to compose it up and you are ready to go. So from here we can see the logs of worker as well as the backend. That's why I have started it. And this will be the main interface of our tool. So first we will run a discovery scan for which we will need the IP. So the Ethernet 1 is the interface on which the CCTV camera is connected. I will run a discovery scan. The discovery scan consists of a simple ping sweep. It sends an ICMP echo packet to each and every device or the IP, and then whichever device replies to that, it marks it as an alive device. So the scan is in progress. I will show you up till then the backend as well as the worker. So the worker has received the task as you can see here, and it is performing the scan. As you can see the code 200 and OK, which tells us that everything inside the backend is moving correctly. And you can see the task has got performed successfully, and it was able to identify 3 alive hosts. .100, and .106, from which the .106 is a client machine on which we are gonna perform attacks from the 104 attacker machine. So we will switch our tab to the assets. In assets, we can see there is sections, and the 106 is currently mentioned as it's a not CCTV camera. We will perform a full port scan on it, and then we will do the further identification of uh, web directories and streams. So the worker has received the task to run a Nmap scan, and yeah, it has successfully ran it. It was able to find 4 open ports. It was not, I didn't customize the scan. From here we can really customize the scan to a next level. We can identify the OS, then we can identify the service versions, and we can even give it a timestamp of with how many rate it should send packets to the device. So from here to the asset section, once again, we can now see the IP is marked as a CCTV camera. It identified it via RTSP, so real-time security protocol, which was being used in Media MTX for authentication. It identified that and was able to decode it as a CCTV camera. From here, we can do a lot more things too. Uh, just for the demo, we will be doing a sweep web port, and the web port sweep has been completed. Here you can see that the server is named as Media MTX. So we understood that it's a Media MTX, but we still haven't understood the exact version. So to identify the version, we can do the version enumeration from the scan section. From here, we can do the version enumeration. Then we will try to identify the web directories. The web directories are currently identified via brute forcing them. So on the cam1, you can see there is a status of 401 which states that it's an web directory which requires authentication, and we will even try to do an stream discovery via brute forcing, and yeah, we were able to identify the cam1, and if we click on it, we are getting asked for username and password. So as I know it, I can just type the username and password, and as you can see, the live stream has started here too. So to wrap it up, currently the auto vulnerability assessment and pen testing tool for CCTV and DVR is about 25% complete so far, but the main pipeline is already working smoothly. Initiation, scanning, reporting, all of this stuff is automated via just few clicks. Next, we are planning to add a AI-based vulnerability prediction and real-time patch suggestion, so the tool becomes even more smarter. The version is simple, makes CCTV security audits fully autonomous, helping users find and fix issues before attackers do. That's it. Thank you for giving us your time.